So a warm welcome everyone to this seminar arranged by the Swedish Center for Impacts of Climate Extremes. We have today with us Alexandra Schneider from the Institute of Epidemiology at the Helmholtz Zentrum in Munich, who's going to tell us about air pollution, health, and climate change. And this is part of a seminar series where we try to look at impacts of climate and climate extremes in different sectors. And so we run about a seminar every month or 2 months. And if you're not signed up to the Climes newsletter, the center's newsletter, then I warmly encourage you to do so. And contact me if you don't know where to find the sign-up link. So please, Alexandra.
Many thanks for the invitation. I'm really happy to be here and be able to give a talk, maybe just briefly who I am. So I basically am a meteorologist, but then got interested into epidemiology, and that's how I combine the two. So I'm a meteorologist and epidemiologist now and work at the Institute of Epidemiology in Helmholtz Munich and lead my own research group there, Environmental Risks, where we look into all kinds of environmental factors on all kinds of health effects in adults mostly. And so health effects are also mostly cardiovascular, respiratory, and metabolic diseases. Yeah, so let's start. It doesn't move, of course.
If you click on this, if you
yeah, okay. Yeah, that's easier. Okay, super. So I mean,
oh yeah, if you click OK there, that should disappear.
Oh, I can see that on my screen.
You can move the mouse to the second screen. If you move it up the side of your computer screen, it should appear on the.
No,
I can see it.
Let's see it. Wait.
Well, what should appear?
Let's see.
Because that's not there.
And then this is in German. Is anything saying hide meeting controls there?
Yes, that one.
This one?
The second.
Yes.
Yeah.
Excellent.
Okay. Thank you. Okay, so when you talk with people about climate change, usually the population thinks mostly about weather extremes. So that's why I brought this map from Germany, where the German Weather Service each year summarizes like the weather extremes. So places with the highest rainfall, the lowest rainfall, the highest temperature, the lowest temperature, most storms or strongest winds and things like that. And then if people look at these extremes, they start getting, again, it's not moving. Now it's not moving anymore. I don't even see my mouse here. Now.
Yes.
Okay. So there is actually a survey that's called What Worries the World? And so they do this in a regular time frame, so I think 4 times a year or so, and they ask like 25,000 people across the world what their worries are actually. And so you can see here, so I have the last survey from October, how many people are actually worried about climate change, and you see worldwide there are about 13% of the population, or the people from the survey, are worried about climate change. I mean, in Germany, the percentage is a little higher, and you see here also Sweden, I didn't mark it. It's a little higher than worldwide, but you also see that when they did the survey in the last month, that people are getting less interested in climate change at the moment. And what would you say, because they ask what worries the world, so of course people also answer different things than climate change, and then they rank it. So what would you think where ranks climate change? Like, is it the worry number 5 or the worry number 500, or So what is your guess?
20.
3.
3? Not so high. So it's number 9. And it's very stable at number 9. So I followed this survey for several years, and it's even if the percentage changes a bit, the rank is always number 9. So you see also the other worries that rank actually higher than climate change in the feeling of the population. Yeah, and you also see that there is, of course, more and more interest, nevertheless, in climate change. So you can see here what people are looking for in Google when they look into health and climate change, and you see a steady increase of searching for these terms. And you also see that here a bit by country. Who is looking more into climate change and health than others. And also scientifically, there is quite an increasing interest in this topic. So you see here, it's separated by topics like mitigation and adaptation, but you see there's really a strong increase in publications on this topic. And so why are the people actually worried and interested in climate change? And I just wanted to show this little thought game. So here you can see a model how people think the climate will feel like in the year 2050 in the different cities. And so what the temperature in the warmest month in the year 2050 will be and how it will feel like. So for example, Vienna will feel like in 2050 like Skopje, or Madrid will feel like Tehran, or Berlin will feel like Canberra. So this is something that you can actually use to make people a bit more aware of how climate change will act. And this is the warming stripes. So some of you probably have seen them already. Usually I show the German ones. For this talk, I now downloaded the Swedish ones, and they differ, of course, a bit, but nevertheless, what you can see is that it's getting redder and redder. So, I mean, each vertical line represents a year, and then you take the average of the reference period, so that's 1961 to 2000, and then you always calculate if the respective year is warmer or cooler than the reference period, more or less, and then you give the blue color for the cooler years and the red color for the warmer years. And so you can see nicely that in recent years it was rather red than blue. And here I made a list of the warmest years actually in Sweden, and it was quite surprising to me because usually I do this table with German data. And here in Sweden, it's kind of interesting that you had some quite warm years very early, like 1934, 1938. So we don't have that picture in Germany, interestingly. So you see that these are the 10 warmest years, and about 6 of them are happening after the year 2000. And so when you compare that globally, the year 2024 was so far the warmest year since the official weather observation. So you see that in Sweden it was like the second warmest year. And when you compare it to Germany, as I just said, then in Germany, actually, all the 10 warmest years occurred after the year 2000, which I found quite interesting. So obviously, Germany is warming faster than Sweden, and Sweden had some really interesting exceptions in these early 1900 years. So in Germany, for example, 7 years of these 10 warmest years were already 2 degrees warmer than the reference period. And so I tried to compare the warming, the average warming a bit. So globally, we are currently at 1.3 degrees Celsius warming compared to pre-industrial times. In Sweden, you are currently at 2 degrees warming, and in Germany, we are already at 2.5 degrees warming. Yeah, and then, I mean, a lot of people usually ask why it makes such a difference. I mean, to have this shift in the mean temperature by maybe 1 degree, 2 degrees. I mean, you would think maybe that doesn't make such a difference. This here should show you how the temperature distribution looked like. So this is an average of the years 1951 to 1980. And you see, I mean, of course, it's a nice normal distribution. You had, of course, the most of the days were like normal temperature, and then fewer days were hot days and cold days. But if you look now into the shift of the mean temperature, it's not just a shift in the mean temperature, but it's a shift of the whole distribution. So the whole distribution changes now. So that's why this 1 degree or 2 degree difference in the mean doesn't tell you the whole story, of course, because now we see that we have now much more frequent hot days. In addition, we suddenly have, when you compare it to the old distribution, we suddenly have the occurrence of extremely hot days, and the whole distribution got wider. So we have altogether more temperature variability, which is actually a point that has not so much been investigated so far about climate change. I brought here a few pictures also from Germany, again, from the German Weather Service, where you can easily see that it's really true that we have an increase in the number of hot days. I mean, a hot day is defined as a day with a temperature over 30 degrees Celsius. And in the 1950s, we had in Germany per year maybe 4 such days. And now this increased by 8 days. So we, in the meanwhile, have 12 of these hot days in Germany per year on average. In addition, of course, the number and intensity and duration of heat waves increased, and at the same time, of course, the number of ice days decreased. So an ice day is a day with temperatures below 0 degrees Celsius, and you can see that in Germany, for example, we used to have 26 ice days per year, and this decreased now by 14 days per year.
Can I just, is this average temperature in Germany that you define as above 30 degrees, or?
So this is actually a worldwide definition of heat days, 30 degrees Celsius.
I mean, is it from some stations or average for all of Germany?
I mean, these temperature levels?
Yeah.
Yeah. So that's an average.
Yeah.
This is a picture I took from the latest Lancet countdown. So here we have also the average annual heat wave days in the years 2020 to 2024 by different regions. So we have here the different continents, for example. So the darker blue shows you the expected number of heat days you would have without climate change, and then the red arrow shows you what came on top in this number of heat days because we have climate change. So you really see the increase, and the increase is not only in Germany, as I showed before, but of course worldwide. And then on the other right-hand side, you can also see that there are more and more households now using air conditioning. So this is also, of course, a sign that people are aware that heat can actually have an influence on their well-being. But of course, so that this is shown by the different human development index, which is kind of a marker for socioeconomic status. And then you of course see that the lowest category, there's no change in air conditioning, because of course they cannot afford that. They certainly would also need it, but so that's a very typical picture. But we wanted to talk not only about the exposure part, because I think that's what you work on here anyways a lot, so you you are aware of this, but I wanted to talk more about the health effects of heat. And of course, I mean, when you talk about health effects of heat, people often think just about like heat strokes and dehydration. And this is, of course, the first and most extreme effect. But what I would like to focus on now in the coming minutes of my talk is that you also observe many more deaths caused by cardiovascular disease, respiratory disease, also renal disease, and even metabolic diseases like diabetes. And the same is true for hospitalization. So heat periods, high temperatures lead to an acceleration of death and hospital admissions. And so this is a quick overview on what kind of health effects we can expect from heat exposure. So the evidence shows that we see it mostly in every part of the body, in every organ. So we, for example, found effects on the brain. So there's an increase in the number of strokes. We find effects on the lungs. So the people with COPD and asthma are affected by heat and heat waves. Then we see it, of course, in pregnancy outcomes with preterm births, for example. There are more with heat periods. Then I think very obvious is the effect on the heart. That's something that everybody can imagine, that heat has an effect on your heart function. So, for example, we see an increase in myocardial infarctions during heat periods. And then, of course, also your kidneys are affected from heat. And what I said before, I mean, the most extreme ones are the heat strokes and the emergency room visits. And there are specific susceptible population subgroups that are affected by heat. So evidence shows that people older than 65 years are most susceptible than people who already have chronic diseases or take specific medication, then overweight people, then babies, toddlers, and pregnant women, because their thermoregulation is affected by being young or being pregnant. Then, of course, people who work outdoors. And then we also found that people who live in social isolation are especially affected, and people with low socioeconomic status. Yeah, then the year 2003 was one of the hottest years and had the longest heat wave we so far experienced. At this time, also the countries were not really prepared for heat effects. So you see that the 2003 heat wave in Europe had like a crazy death toll, especially in France, but also in Germany. I mean, Sweden is not listed here as one of the most affected ones. Yeah.
Well, it's not that in Sweden, actually.
Yeah, exactly. So you see that here on the map where it was hottest. So yeah, you're right. Yeah, and so I mentioned these very clear and direct effects of heat, so the heat strokes, for example. And if somebody dies of a heat stroke, then the death certificate clearly states that this is a death coming from heat. Whereas if you die from myocardial infarction, which might also be caused by heat, then it's not shown on the death certificate. And so this study here in Chicago, they wanted to show that if you just look at these death certificates that are really showing this is a death by heat, then you totally underestimate the death toll the heat wave takes. Because they showed here, so I take this funny thing here. So this is the temperature in the year 1995, and then this is the where's the temperature? The orange one is no, they don't show the temperature of the years before here, huh? No. So the orange one is the average daily death from the reference period, so the 10 years here, and then they took out the 1995 year, and so you can see the heat wave in 1995, and this is like the increase in mortality caused by this heat wave. And so they calculated the excess death rate due to heat, and this was about 700 cases. And then, but if you looked, as I said, only at the death certificates where it said this is a death by heat, then you ended up with only 465 heat-related cases. So this clearly shows the underestimation you do if you only look at these death certificates that clearly show it's a heat-related death. And that's why I was confused, because here they show the different temperatures as well. So this is, for example, now the 2003 heat wave in Paris. And here you see here's the temperature in the reference period, which is 1999 to 2002. And then this darker one is the temperature of the year 2003. And then the same is here for mortality. You see the lighter gray is the mortality of the reference period, which stays here below. And then the darker one is the mortality peak due to this crazy heat wave. And so you see clearly two things. So the mortality increases very immediate. So you see that there's almost no lag time between the temperature exposure and the mortality. And you see that it's really an extreme peak. And this is also not caused only by like heat strokes. So it's also other mortality like cardiovascular, respiratory disease mortality. Yeah, and so when you do the statistical analysis between temperature, exposure, and health, I show you the usual exposure response function you get. So usually your temperature mortality association looks like U, V, or J shaped. So you can see that here nicely. And then the left part is the increase due to lower temperatures, and the right part, the red part, is then the increase in mortality due to high temperatures. And in this part here, they often call this part minimum mortality temperature. So this is the temperature where you see the least mortality activity in your population. And we did such an analysis in a big EU project called Exhaustion. And in this project, we were only interested in the right part, so only in the heat part. And we estimated the temperature effect So we used from the temperature distribution, we compared the 99th percentile to the 75th percentile of the temperature distribution and looked at the relative risk for mortality, and then looked into cardiovascular and respiratory effects. And what was kind of surprising to us is that the cardiovascular effects were lower than the respiratory effects. And we did this in 204 different European cities. And if you look at the one from Sweden, you see that the effects are, of course, because of the climate here, a little bit lower than the average for all of the European cities. It's still not 100% clear why the respiratory effects are actually higher than the cardiovascular ones. I mean, there are speculations that it's mainly driven by COPD and asthma patients that react strongly to heat exposure. And also other studies find this, so it doesn't seem to be just a chance finding. And this here's an example from Germany, from Augsburg. So Augsburg is a city about 50 kilometers from Munich. And there we have our study center, and there's also a big myocardial infarction registry. And this gave us the chance to look at all the myocardial infarctions there between 1987 and 2014. And we thought we are interested in different time periods because we thought, yeah, if there is really climate change, maybe people react differently in the different time periods. And what we found actually in the earlier phase here is we see a clear cold effect. And so this is something that cardiologists are aware of. So this is known for decades that cold has an effect on heart disease. But it's interesting that the cold effect remained in the second period, but then we suddenly also saw an effect with higher temperatures, which has not been there before. And then it's not only, I mean, people usually look at like daytime temperatures or daily means, 24-hour means, but climate change also especially leads to hotter nights. And I mean, it's not super clear now for Germany at the moment. So this is the number of tropical nights in Germany. And you see that, so a tropical night is defined as a temperature. So the temperature does never fall below 20 degrees Celsius in a tropical night. And I mean, you see for Germany, we had like 0.1 night on average, and then this increased a little bit. But I mean, in some places, I just looked at one of the German cities that is often record high. For example, in the year 2003, so during this really crazy heat wave, this city Kiel, they reported 21 tropical nights. Yeah. And I mean, the nights are especially important for our sleep, and sleep is important for our health in many ways. And so I think that more research actually needs to be done on nighttime temperature and not only on daytime temperature. And we did that. And not only because we are interested in nighttime temperatures, but because we were contacted by neurologists in Augsburg, and they said that they find it funny that most of their strokes come into the hospital in the morning. And so they thought that something must happen during the night. Because otherwise they would come at different times. And obviously strokes very often occur at night, and then people wake up in the morning and see that they have trouble moving, or I mean all kinds of impairments by stroke. And so that brought us actually to the study. So the Augsburg Clinic is a big center for stroke research, and we then took their cases and associated them with nighttime temperatures. This year looks a bit funny. Of course, in Augsburg, we don't have 50 degrees Celsius at night. But this is a special index. So it's the so-called hot night excess index. And so for this index, we have a certain threshold. So here in Augsburg, it was 14 degrees Celsius coming out of the temperature distribution. And then you take every hour of the night and build the difference to this threshold, and then you add up these differences, because then you have a measure for how much heat you have, because you have the difference to this like average value, and by adding up the different hours, you also kind of see how long the heat is during the night. And so that's why we built this hot night excess index. And then we also divided it again into 2 different time periods, and saw especially in the second time period that the number of strokes increased quite a bit with heat. So we also, so these are the total strokes, and these are subcategories of strokes, but we more or less see a similar picture. And so here are the effect estimates. And so we see here in the second period, for example, that the risk of having a stroke after a hot night increases by 30%. Yeah, and why do we have these hot nights actually? So this is of course due to our cities, how they look like. We miss a lot of green and blue space, as you can see, because that would lead to cooling during the night. And you can see also here worldwide that not so many cities have enough greenness. So I mean here the red dots are the cities that have exceptionally low greenness, and the dark green ones are the ones with high greenness, and the same here for blue spaces. So you can see that our cities would need improvement. Let's put it like this. And that's why in the cities we have these so-called urban heat islands, because of course the buildings with no green space lead to like the cities get hotter and hotter during the day, but also especially during the night. And so you have a temperature distribution from the city center where it's often up to 5 or 6 degrees higher than the outside the city. So, for example, in Munich, we have this big English garden, and when you bike through the English garden during a summer night, it's kind of cool, and then you enter into the city. And it's like a wall. It feels like going into a wall, and it's 5 or 6 degrees higher. Yeah, and just briefly maybe about the mechanisms, because now I told you so much about myocardial infarctions and strokes that are related to heat. So how can you explain how do these severe events really happen? And I mean, there are mainly two mechanisms. So one mechanism is of course sweating, and with sweating you lose a lot of fluid and electrolytes, and this makes your blood thicker, and a thicker blood cannot be so easily transported through the body. So of course your heart needs more power, and it also leads to more blood clotting, so you have more thrombosis. And this then at the end could lead to a myocardial infarction and a stroke. And the other mechanism is vasodilatation. So your blood vessels get wider, during heat, and this happens mostly in the arms and the legs, and therefore the blood goes to arms and legs and is missing in the core part. But the heart still has, still needs to provide blood and oxygen to all organs, and so because it's missing quite an amount of blood, it's starting to pump heavier and faster. And a healthy person can do this. There is no problem, but if you already maybe have chronic diseases or are older, so the susceptible subgroups I showed before, they have problems with this because then it comes to kind of a mismatch in the heart between oxygen supply and oxygen demand, and then at the end this could lead to a myocardial infarction, for example. So these are the two main mechanisms, sweating and vasodilatation. And then there are several other mechanisms that have been shown in the literature. And actually, because we will later talk a bit also about air pollution, they actually share some of these pathways also with like air pollution health effects. And if you are interested in reading a bit more about pathophysiology, there's a kind of nice paper that puts together a matrix and says 27 ways a heat wave can kill you. So they put together the different organs and the different mechanisms and then point to the different references that have shown these associations. Yeah, and then I said in the beginning that climate change also leads to more temperature variability, and that this is not so much considered so far. And this is actually a newer study that shows that actually we have more temperature variability from day to day with climate change. And so it's not only a change in the amplitude of this temperature variability, but also the frequency. So we see that more and more often that we have these sudden changes between daily temperatures, for example. And we thought that we need to investigate that further. And we actually did that in Sweden. So that's why I brought it here. So we took myocardial infarction patients from the Sweetheart registry, and then we defined temperature variability as the difference of the temperature today minus the average temperature of the last 7 days, because we thought, well, over the last 7 days you kind of get used to the average temperature, and then suddenly you have a change in temperature. Either it increases or it decreases, and maybe this does something to your body. Or in this case, to myocardial infarction. And what we really found is if we have a so-called upward temperature shift, so the temperature increases suddenly, then we see an increase directly on this day. So lag 0 means on the day of myocardial infarction. Lag 1 means the temperature increase happened yesterday, and today I see myocardial infarction. So that's what lag means. And so with increases in temperature, we see actually an increase in the number of myocardial infarctions. So that's here. And then if we look at the other direction, we also see increases, but with a lag of 2 days. So if the temperature decreases, then it takes about 2 days, and then we see an increase in myocardial infarction. So this is one of the rare studies that actually looked at this temperature variability. And then we also looked into another aspect of temperature variability. This is again the strokes from Augsburg that I showed you before. And we looked at summer month and then thought we want to know if so-called summer cold spells do have an effect on the strokes, because I mean you have sometimes in summer sudden temperature drops for 1 or 2 or 3 days, and we actually saw that there was an increase in the number of strokes if we had these cold spells during the summer month. So also here, this is kind of a temperature variability effect.
Yine.
Yeah, and so what I showed you so far is mostly isolated effects of heat.
Olmuştu. Hı. Bakabilir miyim?
It's coming from your computer, actually, I think.
Teşekkürler.
So if we put it on,
Ha, bu babanın.
it
Babanın.
should solve it.
Okay.
Yakına veremem. Çok küçük bir şey. Bu babanın.
So the people online.
It's, I know I see
Sen
with
düşürmüştün,
it first by
hatırlıyorum.
accident.
Okay, so I mean, what I showed you so far is mostly effects of heat alone. But of course, heat doesn't work alone on your body. So you have, for example, other contextual factors that, or individual factors that also contribute to this association. And we did a systematic literature review and looked into inequalities in exposure to objectively measured heat stress, subjectively measured heat stress, and related adaptive capacity. And I need to emphasize that this actually only looked into exposure, so inequalities in heat exposure. So it did not look into the different health effects, so only the exposure side, because it's quite interesting. So what we found is from these factors, of course, socioeconomic status was the most dominant one in literature. And so this is the result for the worldwide evidence. And then you also see, of course, that race and ethnicity had quite an effect, which was mostly driven actually by US literature. And then, of course, you also have age and sex and gender. And if you now look at the European results only, you see again it's socioeconomic status, but then this race ethnicity is like very much reduced. But we have then more migration in it, and then also a bit more sex and gender, and age remains more or less the same. The one of the interesting points was about this age effect. And that's why I said this is only looking at exposure, because I showed you before that for the health effects, it's the older people that are most susceptible. When we looked here into heat exposure, it was mostly the young people who were mostly exposed to heat. So because many of the older people can avoid the heat, they don't have to maybe go to work anymore. They don't have to pick up their children anymore. And they often live in nicer places. For example, students live in cheaper places where they have no ventilation or so. So it's quite interesting that you always have to look if you're interested in inequalities in exposure and inequalities of health effects. So it can differ quite a bit.
We start wrapping up so we keep some time for questions.
Oh, okay, I talk too much. Okay. Okay, so I wanted to show a bit about the air pollution part. So here you also see that heat interacts with actually air pollution. And maybe I show a few slides on this and then we can stop. And so why air pollution as an interacting and environmental factor? And so you can see from the global ranking of risk factors that actually air pollution and temperature rank among the top 10 risk factors for death worldwide. And air pollution is actually number 2, just behind high blood pressure. And why does temperature actually interact with air pollution? Of course, one way is via wildfires. So if it's hot, you of course have more probability of wildfires, and there you get all kinds of gases and also particles. And the other thing is, of course, tropospherical ozone, because that's very dependent on temperature. So the development of like surface ozone. And I just wanted to show a few health effects, which is kind of interesting. So you model then the continuous exposure to temperature and to air pollution, and look here, for example, in Italy, in 25 Italian cities at the mortality risk. And then you pick, for example, here, the different exposure response functions for low, medium, and high air pollution, and look at the temperature effects on mortality in these different categories. Like, so you have a heat effect always here, but this is the heat effect if the day has low air pollution, medium air pollution, and high air pollution. And what you can see is that if you have high air pollution, then the heat effect is even stronger. And so we saw the same thing in Europe. So this was only 25 Italian cities, but if you now look in Europe, you also see that the heat effect increases steadily if you have at the same time high air pollution. So this is 148 cities, and then these are a few ones that I picked, and this is for respiratory mortality, and the same is true for cardiovascular mortality, but as shown before, a bit less strong than for respiratory mortality. And I think we can stop here, because that's just show at the end how much we are actually exposed to heat when we are born at different times. And so you can see, of course, that the youngest ones will experience many more heat wave than, for example, we were born here or so. So you can see how much heat wave you will experience in your lifetime. And this could, of course, also affect maybe your health, because what I showed you so far only talked about the direct short-term effects of heat, but we did not talk about what kind of effect does it have that during your whole lifetime you experience much more heat than the generations before. So many thanks for your attention.
Now we have some time for questions. I suggest I try to alternate some from the room and some from Zoom. Alexandra, if you briefly repeat the question so that people on Zoom also hear. And so one question was, did you do seasonal analysis for the effects of high temperature on cause-specific mortality?
Can you say that again? The seasonal
analyses.
If I did perform seasonal analysis for the effects of high temperature. Yeah, of course we do that. I mean, you can use for the analysis the whole year and the whole temperature range, but then you have to take into account that it has this U shape and that you have the cold effects and the warm effects. but often we also just look, for example, that what I showed from the exhaustion project, we only took the warm month of the year and then looked at the heat effects during the warm month. And then you can also take the cold month and look at the cold effects. And then you can, of course, as I showed in the temperature variability analysis, you could also take the summer month and look at cold spells during summer month. So there are a lot of possibilities.
So air pollution is often most serious when you have like stable conditions like inversion and very low wind speeds. So do you know how it will change with a changing climate, if there will be more or less situations with like stagnant air and inversion situations, or how do you think it will?
That's actually, I think, very difficult to say because there's so much interaction between temperature and air pollution on like global scale and local scale. It's very hard to say how the development will be because it's also a bit, I mean, I read a bit into how climate change actually affects air pollution distribution, and the evidence is very torn. So I mean, and it's very locally dependent actually. So I read that in some parts of the world it's clear that higher temperatures will lead to higher air pollution, and in other parts it will lead to lower air pollution. And but the complete interaction is not so much solved.
I guess there are many effects, like it could be pollution from vehicles and burning, but also from dry land for a long period of dryness that can blow into.
Yes. I mean, as I showed, I mean, of course, we will have, for example, certainly more wildfires, and then we, of course, have more air pollution. And as you say, I mean, the dry lands certainly.
There are a couple of questions online on the Augsburg study. So first one, what is the age and cohort composition of the data you used?
For the myocardial infarctions, I think it was 25 years to 75, if I remember correctly. For the strokes, I don't remember. So we did not have a restriction, and we had some people who had strokes at a young age already. So of course, not so many as the older ages, but I don't remember exactly the age range of the stroke study, but I think it was also around 28 to 80 something, but
Related to that question, both online that I wanted to ask myself, is the effect of the fact that higher temperatures have higher impact on stroke in Augsburg in the present climate than in the past? Is that an effect of changing demographics? Because one would intuitively expect that we have more air conditioning, we become in many ways better at dealing with extreme heat than we were 30 years ago, 40 years ago.
Should I repeat the question or?
Yeah.
Yeah. So the question was if the increase in heat-related like strokes and MIs in Augsburg at the later time period is related to a change in like the population more or less. So I mean, it can be. The thing is, for the myocardial infarctions, we actually saw that this heat increase was driven by people who had certain comorbidities, and these comorbidities increased a bit over time. So these were people who had diabetes before their myocardial infarction and people who had hyperlipidemia before their myocardial infarction, and these were driving this heat effect. I mean, another interpretation is, of course, that we experience now more heat compared to previous times. And so because the heat days were not so frequent, maybe the exposure response function didn't increase so much on the heat part, because we just did not experience so many days with heat. That the people got more susceptible to heat, I'm not so sure. I mean, they could maybe, but
the uncertainty bounds of the two curves didn't overlap, so that means you're underestimating uncertainty if it's a matter of very few days.
Yeah.
Good questions from the room. Maybe one back there, yeah.
How do you use your research and other people's research to affect, for example, policymakers?
I actually have a slide. So this is what I sometimes show when I talk about this question about policy. So, I mean, what we do is we try to, of course, implement policy relevant research. So research that I just showed. The next step would be to communicate this evidence to policy actors. And here are some examples. So, for example, there is this so-called Lancet countdown that comes out every October. And the Lancet countdown also asks the different countries for so-called policy briefs. So with their publication, you could then publish, for example, for Germany, a policy brief for the German politicians. And so that's what we did, for example, with our results. I mean, if they take it up, we cannot say, but at least we tried. And then the next step would be also then to try to participate in the policy dialogue. So, for example, here, this was more on air pollution, where my boss, Annette Peters, tried to talk at a WHO meeting about air pollution guidelines. And actually, the air pollution part is a kind of a success story for Europe, because we tried to make it clear that we need lower guideline values than we currently have. And we showed the evidence from many, many, many studies. And then they really decided for lower guidelines for the year 2030. So this is kind of a success story for air pollution, at least. And then, I mean, of course, we try to do public outreach and inform also the general public. And here, for example, I would like to point to this app. It's called Clever Gesund, so Clever Healthy. And it's an app for young people where they are informed about healthy lifestyle. And we integrate currently also information on climate change and how you can adapt and how you can help mitigate climate change. And this is actually triggered by a big German insurance, so the AOK insurance. So.
Thanks. I mean, we are out of time. So if anyone in the room has questions, please follow up with Alexandra. Apologies for those on Zoom whose questions I didn't manage to pose. Thanks again, Alexandra, and everyone who joined. I can gladly report we had over 50 Zoom attendees. So thanks again.
Thank you very much.